This lesson is exterior angles of polygons. We want to be able to apply formulas for calculating both the measures of the exterior angles and the sum of the exterior angles. So first, what is an exterior angle? It's an angle formed by the side of a polygon and the extension of an adjacent side. Let's look at these two pictures down here and I'll show you an example. Okay, so if we were just to extend the side, that one's not very good, but just extend the side and you create exterior angles. So there's exterior angle 1, 2, 3, and 4. If I look at the hexagon over here, again, just extend each side and I am creating exterior angles. Okay. So you will see that the number of exterior angles is the same as the number of sides of the polygon. If I have 4 sides, I have 4 exterior angles. If I have 6 sides, I have 6 exterior angles. Now, this is a real important rule. The sum of the measures of the exterior angles of a convex polygon with end sides is, you add up all of the exterior angles, and the sum will always be 360 degrees. So look at an example. If I was to pretend this as a square, if I extend each side, okay, we know in a square that each interior angle is 90 degrees. So this is a straight line, so if that one's 90, this one also has to be 90. So all of these are going to be 90. So 90 times 4 is 360. Okay, let's look at another example. Let's look at a triangle. Now this triangle, I did not draw a regular triangle because it doesn't have to be here. Doesn't matter if it's regular or not. The sum of the exterior angles is still going to be 360. So let's pretend this is a 30, 60, 90 triangle. And let me extend these sides. Okay, so here's my straight line. If the interior angle is 60, this has to be 120. The interior angle here is 30, so this has to be 150. And this is 90, so this one is 90. And if you add 150, 120, and 90, you get 360. So it doesn't matter how many sides a polygon has, and it doesn't matter if it's a regular polygon or not. As long as it's a convex polygon, it doesn't like cave in on itself like that, then the sum of the exterior angles will always be 360. So if they ask you for the sum of measures of exterior angles of a undecagon, that's 11 sides, it's 360. If you ask for the sum of the exterior angles of a 20gon, it's 360. If you ask for the sum of the exterior angles of a 1000gon, it's 360. Okay, I probably couldn't draw a polygon with 1,000 sides and show you the angles, but it doesn't matter how many they are. It's going to be 360 degrees. Now, the measure of each exterior angle. So one angle, now this has to be regular. So if it's a regular polygon and you want to know the measure of each exterior angle, you just take 360 and divide by n, the number of sides. So find the measure of one exterior angle of an undecagon, and it is just 360 divided by 11. Now, this can have decimals, so 360 divided by 11 is 32.7. So angles can be a decimal, okay? That's how you do it. Determine the angle measures of regular polygons. So now they give us this chart and they want us to find the sum of interior measure of each interior, sum of exterior, and measure of each exterior. And they do tell us these are all regular polygons. It doesn't matter for the sums, but it does matter for each. So a nonagon has 9 sides, a decagon has 10, and a dodecagon has 11. I suggest that you write the formulas up top, n minus 2 times 180, and then this is n minus 2 times 180 divided by n. Sum of exterior is always 360, so we could go ahead and just fill this in right now. And then each exterior is 360 divided by n. Okay, be careful here. This is n minus 2, so if it has 9 sides, make sure you don't multiply 9 times 180, a very common mistake. It is n minus 2, so it's 7 times 180. And 7 times 180 is 1260. So the sum of the interior angles of a polygon with 9 sides is 1260. And then each is 1260. And then make sure you divide by the 9, not the 7. So 1260 divided by 9 is 140. And then this is 360 divided by 9. And that is 40 degrees. So a decagon, 10 minus 2 is 8 times 180. And that's 1440. And then this is 1440 divided by 10, which is 144. And then this is just 360 divided by 10, or 36. And now 11 minus 2 is 9 times 180. And that is 1620. Oh, I'm sorry. Let me fix this. That's not right, because this is not 11. A dodecagon is 12. Sorry about that. Glad I caught that. So this is 12 sides. So this would be 10 times 180, or 1800. And this is 1800 divided by 12, which is 150. And then this is 360 divided by 12. I think that's 30, but yeah. Always like to double check on my calculator. Okay, so now we filled in our chart, and you'll see a pattern that emerges, but not one that, anyway, as the number of sides go up, the measure of each interior angle goes up. As the measure of sides goes up, the measure of exterior angles, you can see, goes down. So just a pattern that you can recognize. All right. The measure of an exterior angle of a regular polygon is 30. So this is where they give us the answer, and they ask for the number of sides. So remember, the number of sides can never be a decimal, because you can't have a half a side. But this is the formula is 360 divided by n, and they tell us that it's equal to 30. So we want to get n by itself. So I would multiply both sides of this equation by n. And you're left with 360 equals 30n. And then divide both sides by 30. And n equals, that should be 12. 360 divided by 30 is 12. So a polygon, a regular polygon with 12 sides, each exterior angle would be equal to 30 degrees. Okay, good luck.